If you like the video, please subscribe for free.
A black hole is a region of spacetime with extreme gravity from which not even light can escape. The extreme gravity of a black hole can lead to time dilation, where time passes more slowly near the black hole than farther away. Matter approaching a black hole is attracted by gravitational forces and forms a rotating accretion disk, the event horizon marking the boundary. There is no return from the black hole. Spacetime can be visualized as a lattice that bends under the influence of mass. The curvature of spacetime explains how gravity affects the motion of objects. Spacetime curvature not only affects the motion of objects but also the course of time. Mass and energy are equivalent and both cause a curvature of spacetime. A wormhole is a hypothetical topological structure connecting two distant points in spacetime. Wormholes could theoretically serve as shortcuts through spacetime and enable travel over immense distances, but the existence and stability of wormholes have not yet been proven, and are the subject of intensive research. Simulating wormholes helps scientists understand the properties of spacetime and gravity under extreme conditions that special relativity predicts. The fact that time passes more slowly for moving objects relative to a stationary observer, this time dilation can only be significantly measured at speeds approaching the speed of light. The general theory of relativity states that gravity affects time. Stronger gravitational fields slow down the passage of time. This effect has been confirmed experimentally by comparing atomic clocks at different altitudes. Time dilation is a real physical effect and must be taken into account in precise applications, such as satellite navigation. The grandfather paradox illustrates a logical problem of time travel. What if a person travels back in time and prevents their own grandfather from fathering their parents? If the person prevents the birth of their grandfather, they themselves would not exist, causing the plot to travel back in time. This paradox calls into question the principles of causality and the consistency of the timeline. Alternative theories suggest that time travel could lead to parallel universes where the past can be altered without affecting the original timeline. Stabilizing a wormhole requires immense amounts of energy, and accelerating a spaceship to near the speed of light also requires enormous amounts of energy. The energy required exceeds the currently available resources many times over. New energy sources and technologies are needed to meet these challenges. The development of materials that can withstand the extreme conditions of time travel requires innovative materials. Science hypothetical materials would have to push extreme temperatures and resist radiation. Materials research focuses on the development of alloys, ceramics and composites with exceptional properties. Simulations and modeling play a crucial role in predicting the behavior of these materials under time travel conditions. Quantum entanglement potentially enables instant information transfer over any distance. This instant connection could be the basis for future information transfer technologies. Some theoretical models speculate that quantum entanglement could even be used for time travel technologies. However, using quantum entanglement for time travel is highly speculative and requires a deep understanding of quantum mechanics. Time capsules are containers that contain objects and information to preserve for future generations. One challenge is to ensure that the information in the time capsule is readable over long periods of time and remain understandable. Materials for time capsules must withstand extreme conditions such as humidity, temperature, and radiation. Selecting the content for a time capsule requires careful consideration to convey a representative picture of the current time. A causal loop arises when a future event is the cause of a past event. This loop can lead to logical paradoxes, as cause and effect are no longer clearly defined. In a causal loop, an event can be its own cause, leading to inconsistencies. The existence of causal loops would question fundamental principles of physics. Extremely strong magnetic fields could theoretically be used to manipulate spacetime. The visualization shows the hypothetical curvature of spacetime by such a magnetic field. The intensity of the magnetic field correlates directly with the degree of spacetime curvature. Self-healing materials have the ability to autonomously repair damage and restore their original functionality. The integration of nanoparticles or special polymers enables self-healing through chemical reactions or physical rearrangements. These materials are particularly suitable for applications that require extreme conditions or long durability, such as in aerospace. The development of self-healing materials contributes to reducing maintenance costs and increasing the safety and reliability of technical systems. The multiverse concept represents a possible solution to time travel paradoxes. Each time travel creates a new, separate reality within the multiverse. These new realities exist in parallel and independently of each other. The multiverse provides a framework for resolving the logical inconsistencies of time travel. Time travel tourism involves the hypothetical observation of historical events without interfering. The primary guideline of time travel tourism is non-interference so as not to change the course of history. Visualizations show time-traveling tourists as silent observers observing historical moments from a safe distance. Time travel tourism raises ethical questions regarding responsibility and potential influence. Tachyons are hypothetical particles whose speed exceeds that of light. The existence of tachyons would open up the possibility of time travel. So far, there is no experimental evidence for the existence of tachyons. Cryopreservation allows the long-term preservation of biological materials by extreme cooling by slowing or stopping biological processes. Cryopreservation bridges periods that would otherwise be insurmountable. In the context of long-term preservation, cryopreservation serves as an alternative to time travel. The technology of cryopreservation makes it possible to preserve biological materials for future applications. Nanobots could be used to repair cell damage at the cellular level in the future. The application of nanotechnology could mitigate the effects of time travel on the body. Cellular repair by nanobots aims to minimize the damage caused by time travel. String theory postulates that the fundamental building blocks of the universe are not point-shaped particles but tiny vibrating pages. These sides exist in a higher dimensional space with the extra dimensions rolled up at the subatomic level. String theory could provide a unified description of all the fundamental forces of nature, including gravity. String theory has profound implications for our understanding of space and time by suggesting the possibility of additional dimensions and a fundamental length scale. A hypothetical time police monitor and protect the timeline from unauthorized interference. The main task of the time police is to prevent paradoxical changes and their effects on causality. Possible methods of time policing include correcting anomalies or isolating affected periods of time. The technological equipment of time policing allows navigation and manipulation within time. Negative energy is a concept that exists in physics and is different from conventional positive energy. The existence and usability of negative energy continues to be the subject of intensive research and theoretical considerations. Quantum computers visualize the ability to perform complex calculations. These calculations are algorithms required for time travel. Quantum computers are capable of solving complex problems that classical computers cannot handle. Artificial intelligence is used to pivot complex equations. AI systems analyze historical data patterns to simulate potential time travel mechanisms. The simulation aims to understand the theoretical foundations and practical challenges of time travel. The results of AI-powered analysis are visualized and interpreted in real time. The holographic universe is a theory. It states that our three-dimensional universe is the projection of information onto a two-dimensional surface. This theory implies that all the information that describes our universe is stored on this surface. Similar to a hologram, the holographic nature of the universe could revolutionize our understanding of space, time, and the fundamental nature of reality. A better understanding of the holographic principle could lead to new insights in physics, especially in relation to quantum gravity and the unification of the forces of nature. The transfer of information from the future to the past poses fundamental challenges. The integrity and coherence of the transferred information can be affected by unpredictable factors. Paradoxin and causality violations pose significant theoretical problems in the transfer of information to the past. The reconstruction of complete and understandable information from fragmented data streams requires sophisticated algorithms. Singularities are points on the space-time continuum where the laws of classical physics fail. In a singularity, the density and curvature of space-time are infinite. Some theoretical models speculate that singularities could serve as portals for time travel. However, the use of singularities for time travel is purely hypothetical and poses countless unsolved problems. Genetic manipulation allows organisms to adapt to different environmental conditions, points over time. Through targeted interventions in the genome, specific traits can be strengthened or weakened. The application of genetic manipulation extends from agriculture to medicine. Genetic manipulation offers the possibility of making organisms more resistant to extreme temperatures or disease. Experiments can be carried out in the weightlessness of a space station to study the effects of gravity on time. Atomic clocks in space stations allow high-precision measurements of time-atation effects due to velocity and gravity. The relative speed of the space station and the lower gravitational force lead to measurable differences in time perception (IM) compared to the Earth's surface. These experiments help to validate Einstein's theory of relativity and deepen our understanding of space and time. Loop quantum gravity is an attempt to unite quantum mechanics with general relativity. In contrast to string theory, loop quantum gravity postulates that space and time are quantized. Loop quantum gravity could revolutionize our understanding of black holes and the Big Bang. The theory predicts that space and time are not continuous but are composed of discrete, indivisible units. This quantization of space could resolve the singularities in black holes and the Big Bang. The journey into the distant future brings unforeseen challenges that threaten survival. Adapting to unknown environmental conditions is an essential prerequisite for survival in the distant future. Technological progress can be both a solution and an additional challenge for survival in the future. Dark matter is a hypothetical form of matter that does not interact with light or other electromagnetic radiation. Their existence is inferred by gravitational effects on visible matter and the structure of the universe. Theoretically, dark matter could distort space-time and thus affect the movement of light and matter. The exact nature and composition of dark matter are still unknown, and the subject of current research. Exotic matter possesses a negative mass density, a property not found in classical physics. In theory, exotic matter could be used to alter the geometry of space-time and keep wormholes open. The negative energy density of exotic matter counteracts the gravitational force and thus prevents the collapse of the wormhole. The production and manipulation of exotic matter represents an enormous technological challenge. Space colonies could serve as bases for future time travel experiments. The isolation and scarcity of resources in space colonies simulate conditions for time travel research. The advanced technology in space colonies allows the development of time travel technologies. Research into wormholes and space-time curvature in space colonies could pave the way for time travel. Cosmic strings are hypothetical, one-dimensional topological defects in the space-time continuum that could have arisen in the early universe. Their extreme density and tension would generate strong gravitational fields and thus influence the surrounding space-time fabric. Cosmic strings could act as gravitational lenses, distorting the light from distant galaxies, resulting in double images or ring-shaped structures. The observation of cosmic strings could provide new insights into the physics of the early universe and the validity of theories such as string theory. Time travel challenges the notion of a fixed, unchanging course of time. If the past can be changed, the future is no longer necessarily determined by the present. The possibility of time travel raises the question of whether free will actually exists or whether actions are predetermined. The existence of time travel could lead to paradoxes that undermine causality when choices can be changed in the past. Does this affect identity and consequences in the present? The Casimir effect describes a force action between two uncharged conductive surfaces due to quantum fluctuations of the vacuum. The vacuum energy outside the plates is higher than the vacuum energy between the plates, resulting in a measurable force of attraction. The Casimir effect could potentially be used to manipulate spacetime by specifically influencing the vacuum energy. Precise control of the Casimir effect requires advanced nanotechnology and a deep understanding of quantum field theory. Ion propulsion enables the high speeds required for time travel experiments. Ion thrusters use electrically charged particles to generate thrust. The speeds achievable with ion thrusters are theoretically high enough to observe time dilation effects. Time travel experiments require extremely precise control and high energy efficiency. Virtual reality can serve as a simulation environment for time travel experiments. These simulations allow the investigation of possible effects and paradoxes of time travel. The virtual environment allows you to control variable parameters and analyze the results in real time. The accuracy of the simulation depends on the quality of the historical data and the computing power. The information paradox challenges our understanding of black holes. The paradox arises because quantum mechanics requires the conservation of information, whereas the classical physics of black holes does not allow this. One possible solution to the paradox is Hawking radiation, which may carry information from the black hole. Resolving the information paradox could affect our understanding of time travel and the nature of reality. The unpredictable consequences of interventions in the past can lead to uncontrollable chains of causality. The question of responsibility for the unintended consequences of time travel interventions is ethically difficult to answer. The paradox of time travel, in which changing the past could wipe out one's own existence. This is a fundamental ethical challenge. Gravitational waves are distortions of spacetime that propagate like waves. These waves are created by accelerated masses such as merging black holes. Gravitational waves can be used to study events in the universe that are not observable with electromagnetic radiation. Provides a deeper understanding of gravity and the structure of the universe. Fusion reactors represent a promising source of energy for advanced technologies. The high energy density of fusion reactors theoretically enables applications such as time travel experiments. Controlled nuclear fusion produces enormous amounts of energy without the risks of conventional nuclear power. This is the scientific challenge. To design the plasma confinement and energy extraction efficiently, genetic engineering enables the adaptation of organisms to the specific environmental conditions of different eras. Through targeted genetic modification, living things can be made more resistant to extreme temperatures or diseases. The application of genetic engineering methods can significantly increase the survival ability of species in changing environments. Adaptation through genetic engineering offers a possibility. Conserving biodiversity in a rapidly changing world. Thermodynamics includes laws that describe energy transformations and the direction of processes in physical systems. The first law of thermodynamics states that energy remains constant in a closed system. The second law of thermodynamics postulates that entropy never decreases in a closed system. The laws of thermodynamics are fundamental constraints on the feasibility of time travel. Maintaining a state of low entropy, which would be required for time travel, requires an enormous expenditure of energy. Time travel raises fundamental questions about the continuity and change of personal identity. The possibility of changing the past implies that the present identity is unstable. It is potentially changeable.